Good evening, students. So today we are going to see the two layers. That is, first one data link layer. First one is physical layers, and the second layer is nothing but your data link layer. So before that, we will see what we are covered in our last lecture, right? So in last lecture, we will just concentrating on the network layer, that is the layer number 3, right? It's so what are the different functionalities and characteristics of network layer. Uh, then what is the communication protocols, right? The internet protocol, under that what are the two protocols are there, right? IPv4 and IPv6, uh, and among them we have seen the IPv4 and its different header fields, right? Its sizes of each fields, right? Functionalities of each fields that we have overviewed. Then we are seeing the what do you mean by the router, right? The internet networking devices at layer network layer number 3, its functionality, and what are the different types of this router, right? Modular router and the fixed router, right? These two types we have seen. Then what do you mean by routed, what do you mean by routing, what are the different functionalities of it, what are the different protocols under we can consider is routing protocols, yeah, that is EIGRP, BGP, RIP and all that things, right? Then in last we are seeing what do you mean by routing and routing tables, what are the different types, right? Static routing, dynamic routing and the default routing, right? So all these things we have covered in last lecture. So today we will concentrate on mainly two layers. The first one is the your physical layers and the second one is your data link layer. Then we will move towards how data link layer supports our communication across the network, how it will be useful for communication purpose. Then what are the different network infrastructure devices are there, right? In these two layers, right? The first one is your obviously NICs, that is network interface card is there, then network switch is there. What are the different medias, right? So cables, wired and wireless, what are their types, right? All these things we need to cover today. Then we will see how the MAC address and the IP address roles of each, right? And how ARP address resolution protocol can work with respect to our MAC addresses and IP addresses, right? That also we need to see today, right? How ARP can find the destination MAC address when it knows the IP address, right? And vice versa, right? So all these things we need to see today. Okay. So let's start with the first one, right? So in this particular network model, the first layer is nothing but obviously your the physical layer, right? And the second one is your data link layer, right? It will be responsible for the physical addressing, right? For MAC address and Ethernets and all that things, right? Where this particular physical layer is responsible for your connectivity purposes, right? In binary format it will be there. So what is RS-232, RJ45, all these cables and connectors, all that there in physical layer, right? So we'll start. What is the place of this particular two layers in terms of your OSI layer? So first one is your physical layer, then there is a data link layer, right? So we have already covered the upper layers, right? Starting from the application layer, presentation, session, transport, we have already seen. Then in last lecture we have also seen the network layer. In today's lecture we are covering this physical and data link layer, right? So all the 7 layers you must know the what is the functionality of it, right? What are the different protocols under each of the layers, right? In which format they are sending the data into each layers, right? For communication, what are the different communication protocols, what are the different routing protocols, right? What are the different internet working devices are used, right? All these are nothing but the prerequisite, right? So let's start with the data link layer first, right? What is the purpose of the data link layer? If you see in this particular diagram, right, so there is and one system is there, right? The one person is sitting here, and besides him, opposite of him, one system is there, right? And here also, in this particular system, the NIC card is there, right? In this particular web server also one NIC card is there. NIC is nothing but what? Network interface card, right? So in terms of the communication is happen in between these particular two NICs, right? So from web server, for example, the packet will be transferred to this particular system, right? So this particular network interface card, right? So data link layer is nothing but responsible for this particular communication, right, which will be happen in between the two network interface cards, right? Now if, for example, in the web server here the IP address is already given, right? So this is nothing but what your this is for example, this is your destination IP, right? And you are sending packet from this particular source IP, right? The source IP is 1.110 and the destination IP is 1.5, right? So so data link layer is what it do, right? It just encapsulate this particular IP, right? Whatever it may be, then IPv4 is there or IPv6 is there, right? Because if you see in a network layer, the data whichever is we are sending, right, which we can call it as an packets, right? So in layer 3 packets are transferred into the frames. Why? Because in data link layer we are considering the data in terms of what? In terms of your frames, right? So while sending it just converting this particular packets into the frames, right? So and who is responsible for that? The data link layer is the responsible for that, right? And also what is the again next function of the data link layer is it also performs the error detection and rejection for that particular corrupt frames, right? So for example, we are sending this from PC1 to PC2, any one of the data can be sending, right? So it can be transferred that frames into the packets, right? So for example, it will not receive at the end, right? If the frames that is corrupted, right? So all which frames is corrupted, all that things, who is checking all that things? The data link layer itself, right? So this is nothing but your in this diagram L2 and L3 is given, right? L2 is nothing but the layer 2, that is data link layer, and L3 is nothing but your network layer, right? So in network layer, data in terms of your packets, and in the data link layer, the data in terms of your your frames, right? So and data link layer is mainly responsible for what? The communication between this particular two NICs, right? That is network interface cards, right? So what are the services data link layer having, right? The first one is the machine address determination, right? Machine address is nothing but what? It is nothing but your physical address of your system or physical address of your component, right? So for both sending and receiving machine, it can be identified, it can be determined the physical address of both, right? Sender as well as for receivers, right? As I told, formatting of network layer packets into the frames with machine address attached, right? So whatever you are sending the packet, right, in the, at data link level, it will be transferred into the frames along with what? Along with the machine address attached, that is nothing but your MAC address, right? And also the third one is sequencing and resequencing of the frames. For example, if any frames is corrupt, right, then also it can be manageable sequencing and resequencing by the your data link layer itself, okay? Then what are the network infrastructure devices? The first one already we are seeing in data link layer, the NICs, network interface card, right? Then switch router, then media, right? Media in terms of what? In terms of your wired and wireless media, right? What are their types and all that things, and the logical addresses, that is nothing but your IP addresses, right? So we will see one by one. So network interface card, which we can call it as a LAN card also, NIC, right? If you consider in your laptop or in your desktop, right, so one Ethernet port is there, right? Okay, so it is nothing but what? It is nothing but your hardware component, okay? And which it is nothing but your hardware component, and it will be useful for connected you with the internet, Okay, so for internet connectivity, what will be required? The network interface card will be required for your computer or for your system, right? And it is also, we can call it as an ethernet port, right? We can call it as ethernet port, we can call it as LAN card, we can call it as NIC, network interface card, right? So it is nothing but your hardware component. Okay, then next, there are a different speeds for network cards, right? For example, ethernet 10 mbps, right? The fast ethernet, when we call it as, then the speed it is nothing but your 100 mbps, and for gigabit is nothing but for your 1000 mbps, right? Because these all three network interface cards and its speed, right, it will be very much important with respect to your when you are designing any kind of the network, right? Because for example, I may call one student and tell him or her, right, you just drag and drop in Cisco packet tracer one end devices, and with one, for example, with one web server, and you just connect it with one with fast ethernet, right? Or one with the gigabit ethernet, right? Then it must, he must know, right, whatever we need to connect, that particular system is also must have that particular port, right, which we want, which he or she wanted to connect, right? So so all these things we need to kept in mind while simulation we will do in our network design lab, right? So speed of the ethernet is 10 mbps. For whenever I am considering the fast ethernet, it will be 100 mbps, and for gigabit ethernet it is your 1000 mbps, right? So I just given you one screenshot here, the how to find the speed of the NICs and all that thing. So here for example, I am using the wireless Wi-Fi, right? So for that purpose I am using here the Wi-Fi speed, right? The how to check with that, just go to this particular Wi-Fi setting, and here you will see the one Wi-Fi adapter is there. For right clicking on it, you will find here the speed, right? Likewise, you need to check for ethernet as well, right? Ethernet port as well, what is the speed of that particular LAN card? So just right click on this particular ethernet, you will find out the speed of that particular NIC, what is exactly the speed is, right? So you can do that at your own level. Okay, then we will see what do you mean by the MAC addresses, right? So all we know that as the IP addresses and logical addresses are nothing but the 32-bit addresses in whenever we consider the IPv4 addressing scheme, right? So here the MAC address which having a 48-bit, right, which is represented as 12 hexadecimal digits, right? It is nothing but what, media access control. Media access control is nothing but your MAC, right? It is nothing but a hardware identification number, right, which will be a unique one for each and every system, right? Which are each devices which are on a network, right? And we can also we can call it we can use it in your LAN card and Wi-Fi card, right? It is also having one of the MAC addresses, right? So network interface sorry yes, network interface card and Wi-Fi card also having one some MAC addresses is also there, right? If you go see your home router also, right, it having one MAC addresses, right? So MAC addresses is nothing but physical addresses, also we can call it as, it is a unique one, right? And what is the length of it? It is length of the 48-bit, right? Next is our network switch, right? So what is the functionality of the network switch? We can generally use this particular network switch for the broadcasting one, right? So whatever the end devices which are connected to this particular network switch, right, from that we are connected the end devices, right? For example, if you consider in our college labs also, right, so each and every lab is having a one network switch box, right, at upper top of the in a ceiling side, right? So there one network switch is there, right? So from that the each and every piece is connected via LAN cables, right? And for this particular network switch, the cable is come from your centralized server room, right, from 318 to this particular switch, right, from 318 from one router, right? From router to switch there is a one connection, and from this particular switch you are connecting all the end devices, all the computer system in our labs, right? And this is nothing but one, uh, we can call it as a representation for the switch in terms of your Cisco packet tracer. Okay, so how the switch can be in a simulation part, so like this, right? Two are the incoming, sorry, both are the outgoing directions, right, from to both the directions, right? So network switch is a device that used to connect the network devices, right? It is a hardware device that centralized communication between the wired devices connected with the LAN. As I told you, from for example from 301, right, it will be connected to the, all the 30 machines with the LAN cables, right? Then network switch receives the message and sends them to the targeted audience, right? So in terms of 301, for example, the network switch receives the message from the router of 318, right, and send them to the targeted audience, that is nothing but the systems of your 301 lab, right? Then it is a telecommunication device that uses a packet switching to receive, process, forward the data to the destination addresses. Obviously whenever you are receiving the packet, it must be sent to your target audience, target end devices, right? So all these end devices are nothing but your computer systems here, right? Then network switch forward data to one or multiple devices and need to be receive it. For example, if you consider this particular diagram, right, any kind of the devices you can attach with it, right? Router, for example, this is nothing but a 318 router from this particular 301 switch, and from this particular 301 switch you are connected with all your computer system, your printers and all that things, right? Next, then what are the applications of switches? It is a device using computer network physically connected to the device together, right? Switches which are using, which it is nothing but the LAN connections which are connected to all the end devices, right? Then it is mid to large size of LANs contains a number of linked and managed devices, right? For example, if 24 port switch is there, right, then and for example the 30 systems are there in a lab, right, then what happen, then you need to add one more switch into that particular lab, right, for the additional end devices purpose, right? So all that things you kept in mind while you are designing any kind of the network. So this internetworking devices also plays a major role, right? While you need to identify also the internetworking devices, how many routers you will require, how many switches you will need required to design any kind of the network in any of the labs, right, or any of the organization also, right? So you need to find out all the requirements well before, right? And also you will need to keep in mind that what is the it's the future scope of that particular organization also. For example, now itself there is a 60 intake is there for IT department, right? Earlier, right, now there are now 120 intake is there, that means 60 students are increased, right? So now obviously the labs also must be obviously we have an already a sufficient amount of the labs are there in our college, but if the labs are the shortage with respect to 120 students, right, then you need to again uh, make a what we can call it as we need to understand the future needs as well, right, with respect to the this all the networking part as well. Okay, so if I having 24 ports or 48 ports switches, uh, then we can also add or remove the computer system from the labs as well, right? So this will be your future scope of each and every network designing part, right? That also you need to keep in mind. Okay, then we will move towards the media, right? The networking media, right? The guided medias are there, unguided medias are there, right? So we are mostly use this guided media, right? So coaxial cable, twisted pair cable, fiber optic cable, all are there. And then the unguided area is infrared, radio wave, microwave, right? All these are nothing but your unguided media, we can call it as, right? So we will see one by one, right, what exactly the media is, right? So here if you see this is nothing but your the wired media, right? So whatever the information you need to transfer from one location to another location, from one system to another system, in terms of this particular cable itself, it is nothing but your wired network, right? And without cable, that is nothing but your wireless network, right? Then uh, first of all, we will see what is meant by coaxial cable. I think all the students have already seen such type of the cable, right? Yeah, at your home as well, as for example cable and or a dish. You are using this coaxial cable, right? It is nothing but a single copper conductor is there, okay, and it is nothing but the fitted with the one shield is there, right? Earlier we will use it, but now we are not use it in our computer or LAN products, right? It will be not useful for that now, but earlier it will be useful, right? Next one is that is your UTP, unshielded twisted pair. It will be useful for in your telephone systems, right? It will be useful for your LAN as well, right? If you see in one wire, there are some multiple small wires are there, right? Which will having some of the color combinations, right? And by using that we can connect it, right? So this is one unshielded twisted pair is there, right? Another one is your shielded twisted pair is also there, which will be useful for the data networks, right? We can call it this particular cable as a LAN cable, right? And this particular part of this particular LAN cable is nothing but your connector, right? And this particular connector you need to what we can call as crimp to this particular uh, LAN cable, right? So there are some sequencing over here for the each of the small cables, right? And by the using of that particular sequence, you need to crimp that particular connector to this particular LAN, right? Then only your LAN cable will be active, right? So this color combinations is playing a vital role in this, right? So we will see in later part what it is exactly, right? So these are the some twisted pair cables and their speeds, right? Their frequencies, right? Now depending upon the color combination and how you are crimping all these cables to this particular connector, the speed is depends, right? For example, I need to do an 100 mbps crimping, I need to use 1000 mbps crimping, right? Then there must be some sequence for 100 mbps, there must be some sequence for 1000 as well, right? So depending upon how you are attaching, how you are connecting this particular connector to this particular LAN cable, it will be depends, right? So depending on that, there are some cables already there, right? So cat 6 cat 7 cable we are using, right? Generally cat 6 cable we are used for our lab configuration as well, right? Which having a maximum speed of 1000 mbps, right? So we have in our labs also 1000 mbps as maximum speed for our LAN purposes, right? Its frequency is 250 megahertz. If you consider it is nothing but the twisted pair cables, right? Yes, what I am talking about earlier, right? That the sequencing, okay? So there are again two types also there. The first one is your straight through cable, right? And the second one is your crossover cable, right? If you see, there are some color combination: orange cable, blue cable, green cable, and brown cable is there, right? So how you are connecting these particular cables to over the to the LAN cables connector, right? Depending on that, the cable types are decided, right? Here also how you are able to connect, right? Because that connector is also having these particular color combinations, right? For example, this 1 to 8 is there, this 1 to 8 is there, right? So this 1 to 8 is nothing but the connectors cable, right? And this 1 to 8 is nothing but your cables, your LAN cables, right? And how you are connecting the both sequences, right, with respect to that will be depending on your the types of the cable, right? So straight through cable is one, second one is your crossover cable is there, right? Whenever you are attaching, right? when you connect the two devices of different types together, you are using a straight through cable, right? For example, router to switch you are using, then straight through cable, right? When you connect two devices of the same type together, then you are using the crossover cable, right? Router to router, crossover cable, right? Likewise. So this is nothing but the differentiation between the crossover and the straight cable. Then nowadays we are seeing this particular cable, that is nothing but the fiber optic cable, right? Are the latest development of in cabling technology, right? Which will be we can call it as a very fast, right? As a wavelength of light, it having a speed, right? What is the functionality of it? It having a high bandwidth capacity, right? And it is a long distance between the devices. We can use this particular fiber optic cable, right? So in our college also we have a one connection with our fiber optic cable, right? And also we have one backup line in which is not fiber optic, but the main line which we are having, that is that's but the fiber optic line, right? Then next is the wireless transmission media, right? So we are talked about much on the wired network. Now we will move towards the wireless transmission media, right? Because now everywhere there is an Wi-Fi and all these are there, right? So wireless transmission media is also we are using for transmitting information or packets, right? And because it is more convenient than installing cables, right? So installation cost will be less in wireless transmission, right? So wireless transmission media in location where it is impossible to install cables, right? In that also it's having an advantage where we cannot install the cables, right? So in that area also this particular wireless media we can use, right? So there are some types again in that also, for example infrared radio, cellular radio, microwaves, and satellites and all that things. These are the some of the types of the wireless transmission media, right? So from satellite also, how the microwave signal can be come to the our earth base stations, right? And how we can amplify the signals and broadcasting it to the number of base station, and from that we will receiving all the signals, and how this particular communication can be happen, right, in the wireless media. That is one also one of the example with the help of this particular satellite part. Okay, then we will see how the MAC address table can be look like, right? So here I am giving one example. For example, I am just configuring here the switch of virtual LAN I have configured. So for example, this particular two switches are there, switch 1 and the switch 2, and for each switch some end devices are connected with the help of some Ethernet. That is, for example, here I am considering from switch 1 to PC1, I am using the fast Ethernet connection of first port, then fast Ethernet connection of second port I am using this PC2, fast Ethernet connection of third port I am attaching here the end devices PC number 3, right? Likewise, from switch 2 to PC4 I am using here the fast Ethernet port on the first port of this particular switch 2, right? And in between both switches I am using here the gigabit Ethernet of first port of this switch and first port of this switch, right? So this is nothing but your gigabit Ethernet, which having an speed is of 1000, right? And fast Ethernet is having a speed of your 100 Mbps, right? So all these we are already seen, right? So this green dot is nothing but what the connection is successful in between the all the networking component, all the networking devices. So you can easily you can ping it and you can check the connection in between whether the packet is transferred successfully or not, right? So all these things we will see in our practical thing, right? So here there are some virtual LAN I have created, and for each of the switches I am determining the MAC addresses, right, for each port. For example, this fast Ethernet 0/1 I am having this PC1 which having an IP address of this particular IP address 1111.1.1.1, right? Likewise for PC2 I am having different, from like PC3 I am having from different. So this is nothing but the MAC address of each of the systems, right? And then next is for example there are again two addresses are there for each and every system. For one is the physical addresses, right? And the second which we also call it as the MAC addresses, and the another one is nothing but your logical addresses, which we can call it as and your IP addresses, right? So MAC addresses we already seen, it will be useful for NIC to NIC communication, right, on the same Ethernet network, right, network interface card to network interface card. And for the IP addresses, it can be useful for sending the packet from source to any of the destination devices, right? And same thing will be happen in your remote network as well, right? And for that purpose, in a remote network we are using the ARP thing, right? ARP means what? Address resolution protocol, right? Will be useful for IPv4 addresses to the with the MAC address of the devices NIC, right? So how, for example, in this particular diagram, if you see, right, here I am writing here, I need to send information to so and so IP addresses, but I only have the IP addresses. I don't know the MAC addresses of the devices that has the IP addresses, right? The first system is telling that I know only the destination IP address, but I don't know the MAC address of the next system, right? In that case, who is helpful? In that case, the ARP can work, right? ARP is useful for finding out the destination MAC addresses when you know the IP address of that particular system, right? So it will be very useful. So what are the two functions of this particular ARP? The first function is what? It will resolve the IP addresses to MAC addresses, right? And the second one is it also maintain its own table, is ARP table of IPv4 to MAC addresses mapping, right? So what is the IP addresses, and with corresponding to the MAC addresses of that particular system, it also maintain its own ARP table, right? We like we already seen last lecture, there is one routing table, right, which having some all the interface IP addresses, source IP, destination IP, and all that things of that particular path, right? So every router is maintains the routing table. Likewise, ARP is also maintain its own ARP table, right? So what are the things are there in ARP tables? If we see, whenever you fire a command show space IP space ARP, that is address resolution protocols, right? Then you will see there is one addresses, IP addresses there, and corresponding the hardware addresses also there, right? And also it will be showing you the interface, right? What is the what Ethernet type you have connected with particular these devices. For example, it's showing here the gigabit Ethernet, that is nothing but your 1000 Mbps Ethernet. It will be attached what is the hardware address and what is this its IP addresses, right? So it is nothing but your ARP tables, right? So for example, if you want to check for each and every physical addresses or logical addresses of particular interface, then you just need to fire a command ARP space -a is for all. So it will be gives you an IP addresses as well as the MAC addresses of all the system which are connected with that particular interface, right? So this is all about your ARP tables. Okay, so now we will wind up here for our two layers. The first layer is the physical layers and the data link layer. So what we have studied today is the first two layers of functionalities, right? What is the physical layer, what is the data link layer, then what are the how the data link layer supports the communication, right, from NIC to NIC, how the communication can happen, that also we already seen. Then there are different infrastructure devices, right? The network interface card, we also called it as an Ethernet, we also called it as an your LAN card, right? Then we seen the switch, right, which will be useful for broadcasting any packets, right? It will be useful for sending a packet which are connected to the end devices to that particular switch. Then media, right? Fiber optic, wired and wireless media, then fiber optic cables, then straight through, then crossover cables, how the connectors are there, what is the sequencing of the cables are there, right? That also we have seen. Then what is the MAC address and the IP addresses, right? then how the ARP can be work. If you know the IP address of the destination and you want to know the MAC address of that particular system, then how ARP can use, and how ARP can update its ARP table by its own, and what are the fields of it, what are the command for seeing that IP addresses and MAC address with the help of the ARP, right? So all these things we have seen in this particular lecture, right? So now again a quiz time. So I just send one link into the chat box, right? So total there are 4 questions, and again 3 minutes you to solve that particular quiz. Okay, so quiz is mandatory for all, so attempt that quiz. Okay, and we will so we have end up with here the prerequisite for our subject, that is end, right? I have used, or I have invested 4 to 5 lectures on this particular prerequisite of in, because it already you have covered this in computer network part, but it required some revisions, right? Because it will be helpful when understanding the concept of your enterprise network design subject, right? So from next lecture we are going to start with our chapter number 1 for enterprise network design, right? So thank you for joining. Okay, let's meet in the next lecture. Thank you.